Hi, my name's Bagge, and we're going to concentrate today on a better way of teaching and learning programming. We're going to look at programming concept first, and then using a wonderful strategy called PRIMM. Learning to program can be a bit of a mountain to climb. You've got all those concepts you've got to learn, and then you've really got to be able to read code before you can change or create your own code. PRIMM helps us to smooth out some of that rocky climb. Learning about a programming concept before we actually start programming can really help children. Here, the children are looking at a count-controlled loop. They're looking at an everyday example that they can relate directly to their lives. They're not having to worry about the blocks or the code or any programming language. They can act those out. They can write their own simple algorithmic examples. This really helps children and smooths the way into a successful understanding of programming. After children have learnt a new concept, then we want them to go and really think about it deeply. And this is where PRIMM comes in. Predicting what the code will do when it is run, running the code to see if the prediction was right, investigating the code to find out how it works, modifying code, and making new code. The first phase of PRIMM is predict. Pupils are provided with printed code on a piece of paper that they can examine. That code always uses the concept that they were introduced to earlier. They have to try and predict what do they think that code will do when it is run. In the next phase, children share a computer to run the code and see if their prediction was correct. In the investigate phase, children are asked questions about the code that they will need to run and observe the code really carefully to be able to answer. They will record those questions on their worksheets separately, so that if they disagree with each other, they don't have to have an argument. They can just write down whatever they think. This forces the children to really think deeply about the code and how it works. When pupils have finished investigating, they can then mark their own work using the worksheets that are provided. If they've got them all right, then they can move straight on. If they've got some of them right and some of them wrong, and they know why they're wrong, then they can also move on. If they've got lots wrong, they can go and talk to their teacher and get some support. If pupils are stuck on a question, then the book version provides help notes that the teacher can use to provide advice and activities to help the children understand what's going on in the code. Students move on to modifying code. Here they're asked to make small changes to the code to demonstrate that they understand how it works. When they finish this stage, they will also mark the work before moving on. In the last part of PRIMM, pupils go on to design and make their own independent programming project. At this point, they have to work on their own. They can still talk to their original partner and discuss ideas, but their work will be assessed individually. One of the reasons that PRIMM is so effective is that it builds on earlier research by Lee and others in 2011 called Use, Modify, Create. Use, Modify, Create really outlined the fact that actually when pupils used code, it wasn't really theirs. But when they started to make some changes to it, to modify it, they get this sort of partial ownership. And then when they finally get to make something of their own, then of course that's their own. We all remember those early days of learning to ride, stabilizers, bikes that were smaller and made just for us. And PRIMM does that same sort of thing of giving you lots of support in the early stages and then little by little stripping that support all away So in the same way that eventually you have that wonderful experience of I'm writing, you also get that wonderful experience of I'm programming. PRIMM uses paired programming really efficiently. In the early stages when children are predicting, it's great having all of those conversations together away from the code. And then, of course, when they do come together to look at the code in the run and the investigate and the modify stages, there's lots of fantastic conversations that go on together. But taking away that paired programming for the final make project means that pupils actually have their own control over what they're making. It's better for assessment because teachers can really see whether the pupil's done it. And it also means that a pupil can't sit back and be a passenger for the process because they know they're going to have to make something independently at the end. Now let's look at an actual PRIMM project, Come Back Doggy. Let's start with concept before code. Dance and song lyrics are a great source of prior repetition knowledge. Reading and acting out simple algorithms are a great way to understand count-controlled loops. Writing their own count-controlled loop algorithm is a great way for the teacher to check whether a pupil understands the basics. Once pupils have a grasp of the main concept that you're introducing, it's time to move on to PRIMM and to look at predicting. These pupils are examining the code carefully to work out where they think Maria is going to go once the code starts. If pupils are struggling to predict, the book version has some hints to help the teacher. Things like pretending to actually act out walking inside a loop. Pupils then run the code to see what it does. In the investigate phase, pupils examine the code really carefully to try and answer some questions. In this case, we're looking at things like which blocks get repeated 21 times. Can you spot which blocks get repeated 21 times? In this modifier phase, they're trying to work out how they can make Maria stop just before she touches the dog. What they'll need to do is actually adjust or change the number of repeats in the loop. And of course, they might try quite a few things before they get to that solution. Before pupils can plan and make their own water cycle project, it's quite important for the teacher to just model how we could plan our own animation here. So what they've done is they've drawn a basic water cycle and then they've just planned the type of things you might do to move some of the sprites, so that pointing the sprite to the right and looping 100 and moving one step within it, and then the next step of changing it to a darker cloud when it gets there, and then we've got more bits of the algorithm to build onwards. And that will really help children when they come to actually make their own model and plan their own model. So let's just have a little example of how it could be created using Scratch to recreate part of the water cycle. You can find these resources at code-it.co.uk/Virginia. And in the 4 Learning Primary Programming Scratch books with modules for grade 2 and grade 3, grade 4, grade 5 and grade 6. Each module has been carefully linked to Virginia state standards in a wide variety of subjects, from computing to health to history and social sciences, science, wherever it fits in, helping teachers to cover more in less time. Scratch template documents have been adapted to suit Virginia state standards. We've used the latest research to map out a progression of concepts. Finally, let's say a big thank you to all of those researchers who have influenced the work here. Thank you very much. You can follow these links to access the curriculum and the books. I'm Bagge, and it's been a pleasure to make this video for you.